different when it's written in formula form, but we already know which ones are reciprocals, don't we? What's a reciprocal of sine? Cosecant. Reciprocal of cosine is secant. Reciprocal of tangent is cotangent. So if you look in your book, it will tell you that sine of theta is 1 over cosecant of theta. That's what it means to be reciprocals. And it works in reverse. Cosecant of theta is 1 over sine theta. It's just explaining that they are reciprocals of one another. If you know one of them, all you have to do is flip the fraction to get the other one. The reciprocal of cosine we said was secant. So cosine of theta is 1 over secant theta. Or secant theta is 1 over cosine. And the last set, tangent of theta is 1 over cotangent theta. Or cotangent of theta is 1 over tangent theta. That's what it means to be reciprocal. So if you know one, you can flip it to find the other one. One word of warning for you. If you are looking on your calculator, so you'll notice, like these graphing calculators or even the other ones, they have buttons for sine, cosine, and tangent. And above them, it says like sine -1, cosine -1, tangent -1. Those are not the reciprocals. Okay, so if I want cosecant, I actually have to do 1 divided by sine. Okay, I don't use those -1 buttons yet. We haven't learned what they mean. So the only things that we know are sine, cosine, and tangent. I will talk more about that in the next few chapters. We'll start using our calculators some more with this stuff, but I just wanted to throw that out there right now. So, if I asked you to find tangent of theta, given that cotangent of theta is equal to 4. What would be tangent? Tangent and cotangent are reciprocal, so if I know one, I can get the other. All right? If I wanted secant, and I told you that cosine of theta was -2 over the square root of 20. So what would secant be?
Radical 20 over -2.
And the negative can go top, bottom, or out in front. Doesn't matter where. Now, for our final answer, we do need to make sure our radicals are always reduced. How would we break down 20?
2.
Right. Breaks into a 4 and a 5, and the square root of 4 is 2. And then what happens? So we end up with just negative square root of 5. So reduce if necessary, but we use that reciprocal property to get there. Okay. Any questions about that? All right. Next thing I want to talk about. We've seen like sometimes our answers are positive, sometimes they're negative, and that is based off our quadrants. So we can talk about the signs of our trig functions. We can know if they're going to be positives or negatives based off where they lie. Okay, we've done some of this already. Remember that one assignment where it would say x over r in quadrant 3, and you had to give if it was positive or negative. We know r is always what kind of number? R is a positive number no matter what. Okay, if you take a point in the first quadrant, what's true about both x and y? They're both positive. So what happens if you do any combination? You're going to divide positive numbers, so everything's positive, right? So in the first quadrant, they are all positive. Okay. In the second quadrant, what kind of number is x? And y is? Okay. So if we think about this, sine is y over r. So sine would be positive. And if sine's positive, what other one would be? What's the reciprocal of sine? Cosecant. So sine is positive, cosecant would be positive. But the others, when I do cosine x over r over x, when I do x over y or y over x, what are all of those? Negative. So in quadrant 2, sine and its reciprocal are positive, everything else turns out to be negative. Okay, in quadrant 3, what's true about x? X and y are both negative. Okay, so when I do sine y over r, that's negative, so cosecant would be negative. When I do cosine x over r, that's negative, so secant would be negative. When I do tangent y over x, what do I get? Positive. So in quadrant 3, tangent and its reciprocal, cotangent, are both positive. Everything else is negative. In quadrant 4, x is positive, y is, okay, so when we do sine, y over r, that's negative, so cosecant's negative. When I do cosine x over r, I get positive, so cosine and its reciprocal secant would be positive. Tangent y over x, or cotangent x over y, those would be negative. So, did I have to tell you if these things would be positive or negative? Could you have figured that out? Yeah, we've done that before. But this is a nice trick for remembering when things are positive based off the quadrants. I always tell everyone, think all students take calculus. Okay, in quadrant 1, they're all positive. In quadrant 2, sine and its reciprocal are positive. Quadrant 3, T is for tangent and its reciprocal. Quadrant 4, C is for cosine and its reciprocal. So that's just a little trick to help you if you need it. Okay. Any questions about how we figured those out? So I'm going to ask a few different questions about these. First one, I just want to decide if these things are going to be positive or negative. I don't know. I think it'd be easier if I just made a table for all of these. Why don't I do that? You don't have to set up your answer like this, but. Okay, if I'm talking about 54 degrees, what quadrant is 54 degrees in? The first. Okay, if you think about your picture, between 0 and 90. In quadrant 1, if we think all students take calculus, in quadrant 1, everything is positive. X, Y, and R are positive. So 54 degrees, they are all positive. If I said 260 degrees. So first, I need to figure out what the quadrant 260 would be in. So this is 0, 90, 180, 270. So it's between 180 and 270. So that's quadrant 3. In quadrant 3, T for take. Tangent is positive. And what's the reciprocal of tangent? Cotangent is positive. That means the other 4 are negatives. Okay, negative 60. What quadrant is that? Two ways to think about it. You could think as spinning down 60, or if you add 360 to it, you get 300. So either way, that's quadrant 4. Okay, in quadrant 4, all students take calculus. C is for what? Cosine. So cosine is positive, and the reciprocal of cosine is secant. So those two are positive, the other 4 would be negative values. Does this make sense to everyone? So if I gave you an angle, could you figure out if the answers would be positive or negative? Let's look at this question. I want to know what quadrant or quadrants the angle would have to be in for these things to be true. So if tangent is greater than 0 means it's positive. If you think all students take calculus, in which quadrants is tangent positive? The third one and the first one. Everything is positive twice and negative twice. Okay, so if tangent's positive, it's either in quadrant 1 or quadrant 3. Cosecant of theta is less than 0. That means it's negative. So I have to pick between quadrant 1 and 3. Cosecant is the reciprocal of sine. When would sine be negative? Right, in quadrant 1 they're all positive, so that's out. My answer is quadrant 3. So quadrant 3 is the only time that tangent is positive and cosecant is negative. B. Sine theta is greater than 0. So greater than is positive. All students take calculus. When is sine positive?
1 and 2.
Okay. Cosecant is also positive. Cosecant is just the reciprocal of sine. So when is the reciprocal of sine going to be positive? The A and the S as well. So quadrant 1 and quadrant 2 both work here. Why don't you guys try one? See what quadrant you would be in here. Cosine of theta is greater than 0. So you can certainly, if you get stuck, go back and think cosine is x over r. I know that r is always positive, so I need x to be positive. Or you can think cosine's positive when they're all positive or when cosine's positive. So quadrant 1 or 4, that's what I'm picking between. Tangent of theta is less than 0. Less than 0 means negative. So out of these two, in quadrant 1, they're all positive. In quadrant 4, tangent would be negative. So quadrant 4 is my answer. That's when tangent is negative and cosine is positive. Any questions there? answers can we get when I do sine, cosine, tangent? Right, so this is talking about the ranges, the possible answers that we can get. Think about sine and cosine. We know sine is y over r. Cosine is x over r, right? If you take an angle and draw a triangle, we know this is like x, y, and r. What's the biggest side in that triangle? R. It's the hypotenuse. So what happens if you take a number and divide it by something bigger? You get a decimal. We're getting something smaller than 1. Now, did we ever find out a situation where we got 1 exactly? So is there a time when y and r could be the same? Like, remember we did talk about some of those quadrantal angles? Those were the weird cases where we can't draw a triangle and we did get sine to be 1 there. And we also know it could be negative depending on the quadrant. So sine and cosine, your answer can be anything between -1 and +1. Okay, you'll never get an answer bigger than 1 or smaller than -1 because you're dividing by r, which is the biggest side. So if we think about cosecant and secant, those are just the reciprocals. We flip these sides. Oops. So now my hypotenuse is on top. So what happens if you take a number and divide by something smaller? You get an answer that's bigger than 1, right? Or it could be negative. It could also equal 1 if we're on one of the quadrants. So the reciprocals are kind of the opposite. You can get anything smaller than -1 or anything bigger than +1. Okay, tangent and cotangent. Y over x and x over y. Is there any rule on if x or y has to be bigger? No. Those can be any number. So these are what the trig functions can be equal to. Sine and cosine, it's only things between -1 and 1. Secant and cosecant are the reciprocals, so smaller than -1, bigger than 1. Tangent and cotangent can be anything. So I want you to look at this slide and just decide for each of these if that would be possible or impossible. First one, can cotangent be a -0.999? Yes, tangent and cotangent can be anything. So this one is possible, or you can just put yes. Okay, can cosine be a -1.7? No, it has to be smaller, or between -1 and 1, so this one is not possible. Okay, can cosecant be 0? No. Cosecant has to be smaller than -1 or bigger than +1. So that can be useful as just a finding your own errors thing. You know, if you're working through and you get an answer, you know if it's reasonable or not. You know, if I get sine to equal a +3, is that reasonable? No, so I know I made a mistake there. All right, let's look at this problem. Angle theta lies in quadrant 3 and tangent of theta equals 8/5. Find the values of the other 5 trig functions. So I'm giving you tangent. There are several different ways you could go about this. What is the definition of tangent?
Y over x.
So what's my x value?
5.
5. My y value?
8.
Okay. Do we agree with that much? Okay, now take a second and think about it. We're missing something.
R.
We need a r. Okay. Are we 100% confident both of these x and y's are correct? So we're saying x was 5 and y was 8 and we ended in quadrant 3. What kind of numbers would those both need to be? Negative. Now why wasn't my tangent negative? 2 negatives make a positive. Okay, so if I give you the trig function, you have to think about the quadrant to know what variable is positive or negative. All right, so now we can get r. So we get 89. Is that divisible by any perfect squares? No. Okay, so some of you are really confident in the x, y, and r definition, which is awesome. You're ready to go. If you are using SOHCAHTOA, no problem. Take a second and draw your picture. We said our x was negative 5. Our y was negative 8, and our r is radical 89. I already gave you tangent, so we don't have to relist that one. Can you tell me what cotangent is right off the bat? Yeah, we know cotangent is just the reciprocal of tangent. Or you could go back and do x over y. Sine, y over r, so that would be negative 8 over radical 89. Get the radical off the bottom, so multiply it on top and bottom, and you get negative 8 radical 89 over 89. Reciprocal sign is cosecant. Probably easier to do the reciprocal before we move the radical, or just think r over x, r over y, so we get negative radical 89 over 8. Cosine x over r, so negative 5 over radical 89, or negative 5 radical 89 over 89. So it's reciprocal secant will be negative radical 89 over 5. If you relisted tangent, that's not a big deal, but I did give you that one, so you don't have to write it down again. So if we know one trig function, we can get all of them. If you didn't pay attention to your negatives at the beginning, we can still get it here because we know in quadrant 3, tangent and cotangent are positive. The other 4 should be negative. And so do a quick check there that we have our negatives where we need them. Questions? Okay, I'm trying to decide how much more. I feel like I can get through the whole thing, but that's a lot. So my options are, you guys pick. All right, we have a couple more identities. Now, I do want to stress, I feel like I'm throwing a lot of information at you today, but this isn't the only time we're going to see it. Okay, these things we're going to talk about, if things are positive and negative every single day. We are going to talk about, is this a possible answer every single day? So these are things that aren't going away, so don't get overwhelmed. We will continue to talk about them and practice them. The quotient identities, what would happen if I did sine theta divided by cosine theta? What is the definition of sine? What is the definition of cosine? Okay, how do you divide fractions?
Times by the opposite reciprocal.
So you change it to times, and you do the reciprocal of the second one. So y over r divided by r, or times r over x. What happens now? So we get y over x. Does that sound familiar? Y over x is tangent. So sine divided by cosine is tangent. Then if I did the reciprocal, what do you think cosine divided by sine would be? For now, this is just like a tool that can help you maybe save a couple steps on a problem. It's not something that's going to be essential for you to use at this point, so this is just some extra stuff that we will be talking about more. Is that okay? The last thing I want to do is our Pythagorean identities. Okay, we keep using over and over again. X squared plus y squared equals r squared. I can actually use this formula to get several different identities. What would happen if I went through and I divided each term by r squared? This is the same thing as saying x over r squared, y over r squared. And r squared divided by r squared is 1. What is x over r?
Cosine.
So this is like saying cosine squared theta. Y over r is sine squared theta equals 1. This is the first Pythagorean identity. This is the most important one, the most common one, because it simplifies a lot of problems. When you have a cosine squared plus a sine squared, I can take out all that mess and just replace it with a 1. So out of all of them, this is the one we will use the most this year. Right now, if I were going to put this on a test or quiz, I would give you the formula. Okay, I'm not going to expect you to memorize it at this point. I will give it to you. But we just need to be able to use it, and I will show you how. That is the only one I will ask you to use. There are 2 others, and just because I think it's cool, I'll show you where those come from, but I will not ask you to use them yet. So we could have gone back through, I divided by r squared, but what if I divided by x squared? Okay, x squared divided by x squared is 1. Y over x squared equals r over x squared. What's y divided by x? So 1 plus tangent squared theta is equal to, what's r divided by x? Secant squared theta. So that's the second one. 1 plus tangent squared theta equals secant squared theta. I will not ask you to use it right now. If you do, if you're using it on your homework, that is totally fine. You're able to use it, but I won't require it. How do you think I would get the third one?
Divide everything by y.
Mm-hmm. Okay, so that's like x over y squared plus 1 equals r over y squared. What's x over y? Mm-hmm. What's r over y?
Cosecant.
So that's the third one that you are free to use, but I won't make you use. All right. So should we talk about how we actually could use these identities maybe? That's all I have left. 2 examples, and then I'm done. So if I asked you to find cosine of theta and tangent of theta, given that sine of theta is negative radical 2 over 3, and cosine of theta is greater than 0. We have a couple options for how to do this. Let's use an identity on this one, and I'll do another one and show you a different option, okay? If I were going to put this on the test or something, I would say, if I wanted you to do it a certain way, I would say use the identity. Sine squared theta plus cosine squared theta equals 1, and I would tell you the formula. So then we just plug in sine squared theta. What's the value of sine? Squared. Plus, what's the value of cosine? We don't know, so that's the thing we're solving for. Welcome. All right. So if I square that, negative radical 2 times negative radical 2 is just 2. 3 times 3 is 9. So if I subtract that 2/9 over, 1 minus 2 over 9 is 7 over 9. How do you get rid of a square? Anytime you add a square root, we do plus and minus. So cosine is square root of 7 over the square root of 9 is 3. Now, I need to decide, is it positive or is it negative? Well, what did I already tell you?
It's greater than 0.
It's greater than 0, so it's just the positive version. So you can use that identity to plug in and solve for the other one. If I asked for tangent at this point, if you have sine and cosine, how could you get tangent? Remember we said sine divided by cosine is equal to tangent. So if I have those two, sine is negative radical 2 over 3. Cosine is radical 7 over 3. To divide fractions, we flip and multiply. Can we leave it like that? No, we have to multiply radical 7 on top and bottom. So we get negative radical 14 over 7. Okay. Yes?
Could you do a radical 2 over 7? Just like put all under one.
So technically that's considered incorrect notation because it's having a radical in a denominator. So, is this a short way of doing it? It has its time and place. Probably would have been better if I only needed to find one trig function. But if I'm going to ask you to find more than one, it kind of gets annoying doing all these identities. What would be the other option? If we have what one trig function is, how do we find all the others? What did we do before? Could we do x, y, and r? So we could certainly do it that way. Let's do the final example for today. If you didn't want to use all the identities. Find cotangent and cosecant. Those are the only ones I know. Or only ones I need to know. If cosine is negative 7 over 25 and theta is in quadrant 2. All right, cosine. What's the definition of cosine?
X over
All right. So we have 7, we have 25. Which one gets the negative?
7 because
Right, r can't be negative. Other thing, if you think about in quadrant 2, the x is always negative, going backwards. Okay, so we would need to find y. Will y be positive or negative? Positive, because in the second quadrant, you're going up, y is positive. we could do x squared plus y squared equals r squared. We get 24. And wait, it's positive because second quadrant. So now if I ask for cotangent, what's the definition of cotangent?
X over y.
So we just get negative 7 over 24. If I want, what was it called? Cosecant. Cosecant's a reciprocal of sine. Sine is y over r, so that would be r over y. Be 25 over 24. Honestly, it's probably a little bit shorter just setting up your triangle or writing out x, y, and r. Once you have those, you've got it. If you still like the SOHCAHTOA, that's fine. Just label your stuff. Your x was negative 7, your r was 25, we got y to be 24. And you think SOHCAHTOA. All right. I know this was a long day. Thank you for sticking with me.